Hi, I'm Fırat. Today we will talk about the features of the go-mutesting. We will talk about the features of go-mutesting library, like the blacklist or the custom mutant sections, and we will talk about how easy catching the mutants. So let's jump to the code. Okay, what mutant basically is, let's say we have an add function here, and we will parse this every section and say I'm changing it with the minus and see if the tests are failing or passing. If the tests are failing, that means it is a good thing and we can kill the mutant. The mutant is that. This is the mutation, right? We are changing something. But if the tests are still passing, that means something is wrong and the mutation hasn't killed. The mutation is living. So we have a new mutation. That means we are not covering this section. And that is actually what mutation is basically. It is changing the code a little bit. Like, for example, we have an error handling section. It is changing like 0 to 1 or returning not 0, but returning 2 and see if the tests are failing or not. This is the mutation test basically. So let's jump to the library and see what do we have in there. So go-mutesting is actually a fork from the original go-mutesting project from the Zimski, but as you can see, the last commit is from 4 years ago, so it is not maintaining it. But the Miss Magenta
Okay.
is maintaining this project, and this project has a lot of features. Like it has built-in mutators, like the arithmetic, like I showed you. Like this, it is changing the plus to the minus or changing minus to the plus, or bitwise, or changing the assigning types, or loop breaks, like it is changing break to the continue and test if the tests are failing or not, things like that. I will show you the built-in mutators in this video, and it has a blacklist feature as well, so you pass mutator cases if you want to. So let's see this project in practice. So in here I have a calculator file like we told a minute ago. Let me come to there, like demo calculator one. Yes, so I've already installed the go install the go-mutesting project. You can run it like this: go install go-mutesting project. I already have it. So after you install it, you can use it like go-testing, and you can, if you use the dots, it will run for all the folder. But I will just use it like for calculator go. And as you can see, it is now creating the mutants, and if it says it is passing, that means all the mutants are dying, they are being killed. That means our tests are covering all of these cases. Okay, great. And we have mutation score is 1.0. 1.0 means, for example, we have 50 success cases and total is the 50 as well. That means we have 1 point score. Let's see, we have some cases like arithmetic example, conditional example, things like that. And let's run our custom project in there. 02 mutation examples. Yep. And run our go-mutesting file for arithmetic project. As you can see, it is changing the code base and all of them are failing. That means the mutants are living because we don't have any test file in here. Okay, as you can see, it has a lot of cases, so I will stop it and I will come to my calculator again because I want to show you another feature, and that is blacklist. So let's say I will run this project again and say I have some specific case and even the mutant is living. I want to pass that case, so I will get it from the checksum. So it is actually creating an MD5 checksum for the every case. In total, we have 39 cases. So I will get this one and I will show you which case is the which checksum. So I will get it and I will create a blacklist.txt file like this and put it in here and say go testing calculator, but with blacklist.txt. Oops, because I don't have it in here, right? Let's create it in here, blacklist.txt, copy, put it in here and run again. Okay, now it is running again. Let's wait. Yes, as you can see, we have 38 passed, not 39 because one is passed. So you can ask how I can find the specific case. I can't understand it with the checksum. You're right. So we have a report JSON in here, as you can see. I will format it. It is generated by the project. And as you can see, the killed count, total count, things like that. And we have all the cases in here. Like this is the arithmetic base one. This is the original code. This is the changed mutated code. This is a diff. It is changing this one to this one. And this is the checksum of it, like the ID of it. You can think about it like that. So you can get that and put it into blacklist if you want to pass it or skip it. I think skip is the better term in here. And that's how you can use the blacklist feature. So our next feature is custom mutator. Let's say we have all the built-in mutators, but we have some business specific case mutator cases. Then we need to do it like this. So we need to clone the project first. You clone it like git clone the project, go-mutesting. I already have it in here, as you can see. So I copy pasted this code into the mutator folder. So I have 3 custom tools, like I have some string literal mutator, I have a number mutator and error message mutator. Like for example, in this function, I am changing the string to empty string, or to the test string, or in the number one, I am changing the number to 0 directly, or I'm changing the error message to this specific message. Maybe we have some specific business cases like this. Then we can do it like this. Okay, I have the project, I clone it. I have a mutator folder, and as you can see, we have all the built-in mutators in here, like assign, invert, base, arithmetic, branch, mutate cases, and I have created a custom folder. And we have all 3 mutators. We have that function that we have talked about. All the mutators must have to implement the mutation class, mutation type that is coming from the GitHub mutator, the specific original project. What this type is, actually, it has a change and reset function. It is actually coming from the, I think it is called, yes, change reset closure pattern. If you want to research about it, you can use it to search it. We need to have these 2 functions, because the first one is changing the code, the executing the code, and the other one is resetting, because if we are changing to something, then in order to revert it, we need to have the original one, right? So this is keeping the original code, and this is changing the code. That's why we have 2 functions. And if you want to dig into more about how we are changing that code, you can search about abstract syntax 3. This is what ASD is. And for example, in this code, as you can see, we have an ASD in here. It is a package in Go. And if you want to dig deeper about what is it, it is not the topic of this video, but if you want to dig deeper the technical details about how we are changing the code, you can research about it. Okay, we have the function, like we will change it from the change, from this is the original one. We are all creating the mutation function. Then we are registering it and saying this is a mutator as well. Then we need to import it, this function, so we can have it like we can run this section. In order to run this folder, custom folder, we have a main Go file in here. As you can see, we have all the built-in mutators, and I've pasted mine in here. As you can see, the custom one, and that's it. Now we can build this project and use it in our terminal or CI/CD pipelines. Like I can say go and build. I already ran it before, that's why it is giving me. As you can see, I'm using not go-mutesting but go-mutesting custom, because I already have the go-mutesting library in my local. So in order to not having conflict, I'm saying it is a go-mutesting custom for the binary. And it says directory not found, because I'm not in the project. I need to go to go mutation. Where am I? The 01. Okay, go testing. Yes, now I'm in the right folder. I'm building it and outputting as go testing custom. I have it in here, as you can see. Now I can say go testing custom, and for example, list the mutators to see our custom mutators. I'm not in the right section. Now I'm in the root. Okay, as you can see, we have now 3 new custom mutators. Now we can use them in our cases. And that's how you can create your custom mutators. As you can see, this library has a lot of features. It is more useful for CI/CD purpose, but if you want to create mutation tests in your code base, maybe you can check out the ooze library. It is a Go mutation testing, and it is inspired by Go testing library as well. They said it, I think, in their README as well. ooze is heavily inspired by Go testing by Zimski, and by extra mutations by for Aviatek. Ours. And this one is more about writing your mutations in your code base. This one is more of a useful for CI/CD tool lines. Like if you want to run it in your terminal, then this is your project. So I will put these two projects in the description, and you can check them out and compare it and give a decision for your case. In this project, we learned that high code coverage doesn't mean high test quality. They are not the same thing. Let's say we have two projects and two of them has the same code coverage, like the 50%, but if the first one is have mutation score like 1.0, 100%, and the second one is 50%, that means the first one has better test quality. The second one is mutation testing is the real way to real quality measure. And same coverage can have different mutation scores, as I told you before, like the example I gave you. And the last one is production ready tool available. As you can see, the go-mutesting is useful for all your CI/CD tool lines. And that's it for this video. We have learned about what mutation testing is, and then we have talked about the go-mutesting library and the features of it, like the blacklist or custom mutations and things like that. And we have talked about the difference between code coverage. If you want to learn about your code test quality, then you need to have a mutation test project and see what do you have. If you want to get your code quality, if you want to learn about your test quality, then you need to have a mutation test project and see for yourself. And that's it for this video. Thank you for watching. May the force be with you.